So hello, thank you very much for your introduction. And thank you, of course, for inviting me, making this presentation around the future of manufacturing. My name is Michel Morvan. I'm the co-founder and executive chairman of Cosmotech. And today I'm going to share with you some insights, point of view about the use of simulation digital twins. And by the way, what we call 360-degree simulation digital twins to improve and optimize operational efficiency in the domain of manufacturing. So, of course, I will share with you what I mean by these simulation digital twins and digital twins, but it's probably something you've heard of and you're wondering, but what is it exactly? I'm going to share that with you today. But before, I want to start from the problem we observe very, very often today, and by the way, much more today than I would say 1 year ago, before the big crisis. And it's a problem people in manufacturing and more generally supply chain and in many industries face, is what I call the contradictory injunction. What do I mean by that? It's very simple. It's the CEO or any very high level senior executive that comes to you guys and says, well, now in the new world we have to be more resilient, we have to be more robust, we have to be more efficient. And so that's the first constraint. They ask you to do that, but at the same time they say, and of course you have to reduce cost and reduce cost and reduce cost. And you're facing that and saying, hey, how is it possible to do both, to do two things at the same time? And it's very, very hard to do. And it seems a little bit contradictory. And the problem people are facing and you're facing is decision-making in a very complex world. But if I would like to take an image, would you feel confident driving without visibility of the situation, meaning you're in your car and it's the dark, it's night, and you have no lights? Or with no understanding of unknown obstacles in big fog, and you have absolutely no visibility. And that's the main problem. You would never drive full speed your car with absolutely no visibility, right? And even if people say, oh, just look in the rear view mirrors, look at the past and you will understand what is going to be ahead on the road. And of course you won't do that. And in a sense, that's what people are asking you to do, to optimize, to do the best, to be resilient, all that, reducing cost and having no visibility on the impact of your decisions. And digital twins and in particular, the simulation digital twins are the answer to that. And by the way, I share with you a quote from BCG that says the first company to deploy digital twin of their supply chains have already gained impressive levels of control over their complex interconnected system, allowing them to identify risks much sooner than previously possible and replace crisis management with mitigation actions. And that's the key. If you want to be able to manage this contradictory injunction, if people in manufacturing, in supply chain, want to be able to make decisions, know the impact of the decision, find the optimal decision to do the optimal decision in this context with a lot of things to optimize at the same time, you need to have visibility. You need to have visibility. And this comes from digital twins. So let's look at this very nice map, right? It's a paper map. It's not a paper map itself. It's a photo of a paper map of France in 2020. And remember, when you were a couple of years ago, when you were traveling with your car, you had such a map, right? And it was very useful. But then something happened. A company called Google, and others, by the way, created Google Map. In a way, a Google Map is a digital twin of the territory you're driving in, right? It's a map, but you have a lot of data on the map. You have here you can see some roads are in green, and you have the road you're going, the way you're going to follow, and you have information about, real-time information. It's kind of a digital twin of the territory, right? That's what I mean when I say digital twin. But then some other company arrived, and they say, oh yes, it's great. And by the way, it's the company Waze, and it has been acquired by Google because they were providing something new. It was digital twin, data from the present, monitoring data, but they also had data-based AI, meaning when you want to make a decision about the best possible way to go from point A to point B, what you want to know is not only what is the shortest path, but you want to take into account, the probability, the risk, to have a traffic jam at a moment, right? So at the moment you have, and you had that in the previous one, you have the traffic jams that occur now, that's data of the present. And with Waze, you can have the traffic jams, part of traffic jam of the future. What do they do? How does it work? That's what I call data-based AI. They look at how it happened in the past, where when you were in such a situation, when the traffic jam occurred in the past, not only now but a little bit further in time, and that's data-based AI. And then there is what people are working on today in the context of maps and digital maps. It's what we call the ways of the future. It's not only the digital twin that tells you how things are now. It's not only learning from data from the past. It's having the ability to do a simulation, and based on the simulation, know the traffic jams that will occur from all the decisions that are going to be made by all the cars. So it's really the visibility on the best possible path, but taking into account not only the traffic jams of today, the traffic jams of the past, but the one of the future that will occur. And you will have the possibility to see that through simulation. And if you look at simulation digital twin, it's here to help you make confident decisions about the future. And it's including all these things that we have seen: the Google Map, the Waze, and the Ways of the future having the possibility to simulate. And why did I take so long time to explain you that on a map? Because it's exactly what simulation digital twin provide in the industry. So it's just doing, like the map, a twin of your ecosystem. In the real world, it's your factory. It can be a supply chain. It can be a shop floor. It can be different shop floor. I mean, it can be a lot of different things. It's the idea to do a twin of this ecosystem. And it gives you the possibility to take a lot of different things together in this digital twin. That's the left part of the picture you have here. You have the real world on the left part, and on the right, you have the twin. You're doing a twin of it. And this twin, you're going to feed it with data coming from the present, from sensors. And you're going, of course, to gather all data from the past. Remember, like Google and Waze. And from that, you can do a lot of things, knowing, where you are in your system. But of course, here, there will be also the possibility to have, thanks to simulation, as we mentioned before with the map, the possibility to simulate. And because you have the possibility to simulate your twin, to simulate your replica, or of your factory, of your shop floor, of your supply chain, you have the possibility to know what is going to be the impact of your decision. Of course, it's not 100% true, but it gives you some visibility. Exactly like the lights in your car. It doesn't put lights on everything around. It gives you some visibility. It's not perfect, but it's extremely useful. So here, simulation digital twin, it's really doing a twin of your system, not only of your machines or of the physical world, but also of the people, of the processes, of the, I don't know, the human resources, the finances, the stock, the everything, and the way all that interact one with the other, and how, when you do something, when you decide to change something, how it impacts everything that is going to happen, and give you visibility on what is going to happen. And of course, then you can have the possibility also to optimize, to say, okay, now I have this ability to look forward. What is it possible to test 100,000 possible actions and their consequences and all the cascading effect to find the best one for my productivity, for example, or to reduce the cost while increasing efficiency or robustness or resilience in case of unexpected events? Well, that's exactly what is going to provide this digital twin. It's a real-time replica and reference simulation that allows you to do what-if scenarios and how to achieve that. And that's what this digital twin. So let me give you a couple of examples on where we use the digital twins. So the first one is related to asset obsolescence management. It's something that we have done with Renault, the car manufacturer. And the question is how to optimize the life cycle of industrial assets while maximizing the return of investment under CapEx constraints. Well, very concretely, you have your equipment are aging, your robots, and you know that you're going to miss parts. They're going to be more and more expensive in the future. And you have your teams, you have to train them to be the more efficient if you install new robots. And the question is, how can you optimize that? And the result that here is described in the context of 3 countries, France, Spain, and Slovenia, 8 factories and 5,000 assets. It's 50 to 80% annual capital investment reductions. So we are talking about big numbers because you do the replica, you simulate a lot of different scenarios and you find the optimal one. And the idea is that you simulate complexity and digital twin, simulation digital twin, and 360 simulation digital twin, meaning that you're going to take into account everything that has an impact. Well, it's really a great way to go and find value in the complexity of the situation. So the second example is strategic sourcing that we did with another customer I cannot cite. The idea is quite simple, how to determine the optimal production location and the most profitable sourcing strategy. So in this case, same, digital twin, 4 import zones, 3 local factories, and 80,000 sourcing strategy simulated. And at the end of the day, because you gain this visibility, you can choose the best way to do that. And you can take into account, for example, because you have this ability to simulate and to represent your system, you can take into account uncertainties. You can take into account the fact that the volatility of the demand over a certain period of time and choose the best possible way to be resilient, to be robust to the volatility of the demand. In this very case, the gain is 10 million euros per year in logistics cost savings. And the last example I wanted to take with you is production flow distribution. And once again, these are only a couple of examples. It's how a large company optimized its production flow and created an optimal production plan under capacity constraint. So the idea, I mean, it's very clear. I'm sure for you in manufacturing, it makes a lot of sense. And you take into account all factories in Europe in which that these factories are providing some different products. You have 4,000 decision variables. The OTIF is greater than 90%. And you can obtain with that an optimized production plan in 2 minutes. While with the current solutions, it takes several days. And of course, the use is absolutely not the same because then you can test a lot of different options. You can do a lot of what-if scenarios and find the best way to operate. Once again, taking into account at the same time complexity, uncertainty, and then you can answer because of these digital twin which give you visibility. What may be the future if I do this? What may be the future if I do that? And what is the best possible way to make a lot of decisions, a sequence of decisions, take into account all the cascading effects in your system, and in this case, to find the best one to reach your KPIs, to reach your target, to reach your objectives. Right, I'm done. Thank you very much for your attention, and I leave the stage again to the moderator. Thank you very much.